So number 7, the secret here is make sure you convert it to teaspoons, right? The 250 milligrams divided by 125 times 5, and then whatever that is. And then you're going to have to divide by 5. But the shortcut, I'll show you the shortcut on this one for number 7. You don't know it already. We know that 1 teaspoon is 5 milliliters. So I can take my order, the 250, divided by what I have quantity, 125. And then we know that 5 milliliters equals 1 teaspoon. So we're going to multiply by our quantity of 1 teaspoon. And then your answer is 2 teaspoons. And sometimes you'll see teaspoon abbreviated just little t. Sometimes you'll see it TSP. And then that's how you differentiate tablespoons from teaspoons, right? Is big T, little t, if you needed that. Okay, let me just see before I get to 22. Okay, and someone said 21. I think I just did 7. Okay, 4. Okay, I saw your, I think I answered your question there, Kelsey.
My 7 is different than yours. I don't know if I have a different practice test.
You're right. I apologize. That was I'm sitting here going, why don't you know how to do that? And I'm looking at the 130 practice test. I apologize. That's
okay, thank you. I'm not doing
right. That's on me. Sorry about that. Oh, okay. So this is your 7, right?
Yeah, thank you.
Potassium chloride. Okay. Yeah. So you're going to set this up the same way. You have your order is 40 milliequivalents. And what do you have available? 20 milliequivalents per 15 ml. So your have is 20. Oops, that's supposed to be a Q. Times the 15 ml. And then another little secret is when you're marking your cup, just remember if it's asking you to mark the cup, that means your answer is on the cup. So we know that the answer is going to be somewhere on here. And then from a mathematical standpoint, it's difficult to get some of these answers. That doesn't mean much to you, but like when I'm writing the test or designing a test, like, and I know that I need to have my answer on the cup, I have to figure out like a creative way if I want to get it to be something like 20 or 25. So it's easier just to do like 30 or 15. Or I could even go lower. I could do 7.5, but this would just be 30 milliliters. Sometimes, and I don't know if this is where you got hung up, is that the milliequivalents, sometimes you're like, well, what do I do with that? It's just another unit. It's the same thing as a milligram. It's as far as how you treat it. It's the same thing as a unit. It's the same thing as a microgram. You're trying to eliminate it. Okay, so that was 7. And I hope that clarified how to do that one. And then I think someone asked about 5 and I was using the wrong test. So you want to know the input output question. So I can help out with that. So there's a very, I would just say straightforward formula that will help you out with this. And I do believe it's in the helpful formula tips. Maybe not. At least not on the old one that I have. No, I guess not. Okay. So this will be a helpful formula for any of your intake output questions. You're going to take your actual output over, we'll just call it the theoretical output times your replacement volume. Okay, that's the formula. So what do I mean by that? So it tells me for every 125 milliliters of out, I have to replace with 40, and that they actually lost 500. So doing that math-wise, my actual output, the patient actually voided 500 milliliters. The theoretical output was the 125 milliliters. And then my replacement volume is the 40 milliliters. There's a variety of different ways to answer this question. And as long as you're getting the right answer, you're doing it right. I just tried to simplify this by giving you another kind of formula to kind of think about if you ever get stuck on, if you have one or two of these questions. Now, here's something as an extra practice. Let's say their actual output, let's just change the variables. Let's say for every 250 milliliters lost, we're going to replace with 120 milliliters. And then they actually lost 200 milliliters. Okay. So their actual output. So again, I'm just making up these numbers. Their actual void, the patient actually voided 200 milliliters. But my theoretical is actually at 250 milliliters and then replacing with 120 milliliters. So I'm still going to put the information in the exact same way. But notice that in this situation, okay, they voided out a lot over a 4-hour time period. Here, they didn't void out a lot over whatever the time period is. And so, but we could still come up with a number. We just know that that number is likely going to be less than 120 milliliters. So if you plug into your calculator 200 times 120 and then divided by 250, you'll actually get a replacement volume of 96 milliliters. So you don't have to, I mean, at least from a mathematical standpoint, you don't have to, have a huge quantity that you're replacing. You just want to stay on top of it, all right? So your patient doesn't dehydrate. All right, I think I saw, so I did 5, I did 7. We talked about 4. All right, and then I think there was a 16, is that right? Okay, good, drop factor. So I will also add that if you go to the additional practice tests or additional practice questions for 220, 230, there's some more questions there for you to work through, particularly more drop rate, flow rate type questions. And if you, and I have worked these through, and if you have a specific question, we can do that. So, yep, those of you continue asking me 25, we're getting there. Working through these other questions too. So I got you. We're going to do, after we do 16 and 17, we're going to do 22 through 25. Okay. So 16 says that you have your tubing or your flow rate is at 75 milliliters in 25 minutes. The tubing says 15 drops per milliliter. What is the drops per minute? So for 16, remember there is a formula for this that's helpful. You take the flow rate, multiply it by the drop factor, and that will give you the drop rate. The flow rate is typically milliliters per hour. Sometimes it's cc per hour, and sometimes it's milliliters per minute. Drop factor is drops per milliliter, and drop rate is drops per minute. Remember, when rounding, you always round to the nearest whole drop. You can't give somebody a partial drop. Okay. So the question says this medication is infusing at 75 milliliters, 25 minutes. So that's your flow rate. The drop factor is 15. Okay, we can confirm that we set it up right by eliminating the units that we are trying to get rid of, the milliliters, and we're left with what we're looking for, which is drops per minute. And so that will equal 45 drops per minute. 17 is going to be set up the exact same way. Seventeen says your patient is to receive Solumedrol 200 milligrams IV. It's received from the pharmacy in a 75 milliliter bag of dextrose 5% water to infuse over 30 minutes. Drop factor is 10. No other IVs are running. What is the drop per minute flow rate? So there's some extra information in here, but let's keep in mind what was our equation. Flow rate times drop factor. So what is my flow rate? The flow rate is volume, 75 milliliters over time, 30 minutes. And there's my drop factor. Okay. Do I care that it's a 200 milligram IV of Solumedrol or that the patient's to receive it? You care in the sense that you want to make sure you're administering the correct medication, right dose, and all that kind of stuff. But from a math standpoint, when we're calculating a rate, I just need to know what I need to know: volume, time, drop factor, conversion factor. I should also say, if you're over at Boyce, South Campus, North Campus, if they ask you a question with the drop factor that's not listed, a lot of times they'll say it's a microtubing, and the microtubing drop factor is 60 drops per milliliter, 60 drops per milliliter. If you're here at Allegheny campus, it will always be given to you. I can't confirm that from an ATI standpoint, but if you're on the ATI and they give you a drop factor question, and you're not sure what it is, that they're probably looking that you use 60 as the drop factor, 60. All right, so this question then is 75 milliliters, 30 minutes. So I don't need to convert hours or minutes or hours to minutes because it's already in minutes, times 10. Okay. And then we do 75 times 10 divided by 30, and you'll get 25 drops per minute. All right, let's move on to the 22 through 25. 22 is helpful because it'll actually help set up 25, particularly the part B and part C2. So the order for this is 0.45% normal saline, 1,000 milliliters IV with heparin, 25,000 units to infuse at 1,000 units per hour, but they want to know what the flow rate is in milliliters per hour. So there's a couple things to know. I'm going to show you two ways to answer this question. Now, because I've been doing this a lot, and I'll tell you this, and you'll see this format in just a moment when we get to the heparin protocol, I would just say you're going from one flow rate to another flow rate, so units per hour to milliliters per hour. It's very similar to how we went from milliliters per hour to drops per minute. We're just converting rates. Okay. I don't know if you've ever looked at like the speedometer in your car. It says miles per hour and it says kilometers per hour. So if you ever find yourself in Canada or somewhere else that's using kilometers per hour and you happen to have your own vehicle there, that way you're doing the right speed limit. Okay. So when you are looking at this here and as a starting point, I would say take your initial flow rate. In this instance, it's 1,000 units per hour. We don't want units per hour, we want milliliters per hour. So how can I go from units per hour to milliliters per hour? Well, I have an IV. The IV is 1,000 milliliters or a liter. And in that IV is 25,000 units of heparin. So we're talking about heparin, we're infusing heparin. Let's use that information. So what you need to know is that the heparin is in the 1,000 milliliter IV bag. So they're together. So when we're writing out a conversion, you either need to make sure that, that they stay together and one's on top and one's on bottom. You never want to multiply those two numbers together because that would just not make sense from a mathematical standpoint. Even if that's something you tried, just know that you were just kind of trying something, and that's okay. Trial and error is what we're trying to do here. But to kind of make things a little bit easier, when you do true dimensional analysis and you know where you're going, we're going to milliliters per hour. We know we want to get rid of units and we want to keep milliliters. So before I even worry about any kind of numbers, I know how I'm going to set this up. Okay. And so then I look at my question. It says 1,000 milliliters, and then it says 25,000 units. So I'm just going to write 1,000 milliliters up here, 25,000 units down here. And I'm going to multiply across the top, divide by the bottom. And before I do any math, I know I've set it up right because I'll be left with just milliliters on the top and hour at the bottom, which is exactly what I want. So 1,000 times 1,000 divided by 25,000 will give me an infusion rate of 40 milliliters per hour. The alternative way to set this up would be to start with, since you know you're looking for milliliters, start with the 1,000 milliliters over the 25,000 units, and then multiply by the 1,000 units per hour. The trick here, though, is that you need to know that these two are together. The 1,000 and the 25,000 are together. And so if you recall that they are, that this is how you would orient them. And then you might, flip this over. Like if I wanted to go from milliliters an hour to units per hour, then I would just invert this, but you're not going to get asked that question, at least not from me. So we're going to get the same answer. So that was 22. For question 23, we're going to do the exact same thing, right? We have a 500 milliliter IV with 500 units of insulin in it, and it's infusing at 10 units per hour. And I want to convert it to milliliters per hour. So step one, what's the flow rate? 10 units per hour. How do I convert units per hour to milliliters per hour? Well, I need to use my IV bag, and my IV bag tells me that I have 500 units of insulin in 500 milliliters of the IV, the 0.9% sodium chloride. Nice little thing about this one is it cancels out. And so your answer is the flow rate is the same. 10 units per hour is the same thing as 10 milliliters per hour for this problem. Of course, that will change. 24 is just kind of like a throwback question. I think you probably have a pretty good understanding of this. 24 is you just take the rate, which is, or the total volume, which is 1,000 milliliters, and it's infusing at 50 milliliters per hour. So you take, and you want to know how long it's going to last. So you're going to take 1,000 divided by 50, and that'll give you 20 hours. Then you have to figure out, okay, well, if it started Monday at 8 a.m., when will it finish? And so if you know Monday at 8 a.m., and you know that 24 hours later would be Tuesday at 0800 or 8 a.m., then just subtract 4 from that, and then your answer is Tuesday at 4 a.m. All right, let's get to the doozy. So I know that for most of you, unless you've watched my YouTube channel or been on any of my other reviews or on my reviews on Tuesday, I know that this is the first time that you're seeing this. Okay. Now I will say, I wish I had written out the heparin protocol to look like this, basically having a border around it. That way, you know that it's a protocol, that it's something that you would see like laminated on the wall and that you're looking at when you're trying to answer some of the questions. And the questions are down here. The A, B, C are the questions. Now there's a couple things on here, and you can see I already kind of keyed it. Some things you don't need to worry about with any of the heparin protocol math that we're going to be doing for the dosage calc test. You don't need to worry about filling in the blanks within the protocol. Those would either already be filled in based off of the, the unit or the hospital or whatever the case may be. Or there might be like, those protocols. And these are just checks. Like, when would you check these things? That has nothing to do with the math. Remember, this test is all about, can you do the math in a, dosage situation. Okay. So a couple things. The first thing is, you're always going to be given the patient's weight. And in reality, that's really one of the few things that I can change in the question in order to, challenge you, I guess, is that we just need to know the patient's weight. So the patient's weight on your actual test will likely be something like, 200 pounds, 155 pounds. It will most likely not be 110 pounds. Okay. All right. There's a couple of pieces of information that are important on here. Step 2 of the protocol tells us what we have available. It says that we have an IV of 25,000 units of heparin, and then that's in a 250 milliliter half normal saline. And you also have a bolus dose available at 1,000 units per milliliter. So those are two different things that you have on hand, which is important because in this question, you're going to be answering two questions. One is calculate the bolus. And then the second question is calculate the flow rate in milliliters per hour. The initial information of calculating the bolus for starting the heparin protocol is stated in step 10 of the protocol. Bolus with 80 units per kilogram, start a drip at 18 units per kilogram per hour. You'll notice that at the beginning of the question, it says the same thing. Protocol, bolus patient with heparin 80 units per kilogram body weight, and then start drip at 18 units per kilogram per hour. It's the same protocol, or it's the same thing written. So this is repeated in step 10. So if you ever get this protocol questions and like that first thing is missing, just know it's here. And if you do a Google search for the heparin protocol, it looks just like this. So I saw this initially in a book, and then one of the textbooks, and then I did a copy paste of this on Google. And like I said, the main thing is I should have put a border around it or shaded it or something. That way you knew it was kind of like a laminated protocol, and you just kind of refer to it to tell you what to do in regards to these questions down here. Now, as far as your test, on your test, you will only have A and B or C1 and C2. Okay. You're not going to have all 4 questions. I wrote all 4 questions here for you for practice. Okay. So whether you like that or not, you got a little extra practice. So let's go through this and I'll show you how to kind of figure this all out. When we look at the questions, it says, first one is calculate the number of milliliters to administer for the bolus. And we're talking about the initial bolus. So that's part A. Part B, what's the infusion rate in milliliters per hour? So we're going to get them started with a bolus dose, and then we're going to have them on a heparin drip in order to help to control their clotting issue, right? So let me get a piece of paper here. And if you've already done this a couple of times, sometimes it's just helpful for muscle memory just to kind of write through it. Even if you've watched me do it, 10 times, just, it's helpful sometimes just to go ahead and write along or write it new. And then we'll do like a fresh one. Okay. So the first thing is I got to take my 110 pounds. And I know that looks like 11016. That's 110 pounds. Just put an S here, but that just looks like a 5. Divide by 2.2, and that'll give me 50 kilograms. Okay. That's probably the one step that everyone was like, I got this. Okay. So for part A, it tells me we want to bolus, and we're going to bolus with 80 units per kilogram. So where I'm getting that information is from the protocol. Bolus the patient with 80 units per kilogram. So I'm going to take that 50 kilograms and we'll multiply by 80 units per kilogram. 50 times 80, 4,000. Now, if the question had said how many units to administer, we'd be done. Okay. And then, you do know that there are syringes that have, units listed, but this question is asking you how many milliliters to administer. So now I have to figure out a way to convert units to milliliters. So I'm going to go back to my available doses. I have an IV bag that has 25,000 units heparin. That's in 250 milliliters, half normal saline. And then I have a bolus dosage strength of 1,000 units per milliliter. This is the one that I want to use because we're calculating and we're trying to figure out bolus dose. So my bolus dosage strength is 1,000 units per milliliter. 4,000 divided by 1,000. My answer is 4 milliliters. And that's how much I'm going to administer for the bolus dose, as my initial start of this protocol. Part B says, now we're going to calculate the infusion rate in milliliters per hour for the IV drip. And then the drip is going to start at 18 units per kilogram per hour. So we have to account for the patient's weight again. So we still have a 50 kilogram patient. This time we're going to multiply by the 18 units per kilogram per hour. And that's going to give me 50 times 18, 900 units per hour. Does that units per hour look familiar to you? When we're talking about heparin, you go back to question 22, 1,000 units per hour. Remember that? Okay. So how do I convert units per hour to milliliters per hour? Well, I need to have a conversion, and the conversion is going to come from when we have somebody. A bolus is a one-time injection, right? Or one-time boost. Whereas the milliliters per hour, the flow rate, is the continuous bringing in of the heparin into the patient. And so it's important that we know that and what we're going to be utilizing. So I don't want to use the bolus dosage strength for calculating my flow rate. I do want to use what I have available in the IV bag. So the 25,000 units, 250 milliliters, half normal saline. So those are the numbers I'm going to use. 25,000 units and 250 milliliters. Now, if you need a shortcut, this comes out to be 1/100. Okay, so just so you know that. So if you are going through this and you're running short on time, once you get to here, divide by 100, and that'll be your answer. Because it's exactly what I'm going to do right now, and I'm going to get 9 milliliters per hour. Okay, so that's the initial protocol, part A and part B. Part C says, the patient's been on that protocol now for 6 hours. After 6 hours, the patient has an APTT of 43 seconds. So I'm going to look in the boxed area, and we're going to look where it talks about the APTT. The APTT has different ranges. And then within each range, there's different protocols to follow. So for this one, it says 43 seconds. We're going to look at step 12 because that's where 43 seconds falls, right? So it falls between 36 and 44 seconds. What are we going to do? Well, we're going to rebolus the patient, this time with 40 units per kilogram, and then we're going to increase the rate by 2 units per kilogram per hour. So let's work through that. So first of all, if initially you're thinking, okay, well, we did 80 units at first and that ended up being 4 ml. If I'm going to do 40 units, it's going to be 2 ml. Instinctively, you are correct. You did that right, and that's good. But sometimes if you only get asked the C part 1 and you don't need to fill out part A, then you still want to know how to set it up, but it's going to be the same setup. 50 kilograms, the same patient, right? Times 40 units per kilogram this time. That's going to give me 2,000 units times my bolus dosage strength of 1,000 units per milliliter. And that will give me 2 ml. So notice that your answer, you're either going to be rebolusing with 80 units per kilogram or starting initially with a bolus of 80 units per kilogram, but you're not going to have any other bolus changes if you get into the higher, like 45 seconds and above APTTs, okay? You might have some changes in your flow rate in the higher APTTs, but you're not going to have any other rebolus. So just know that it's either going to be times 80 or times 40, your patient's weight times 80 or times 40, and then that number divided by 1,000. And that's the setup every single time for these heparin protocol questions.
I have a question, please.
Yes.
So couldn't you just skip this part and just look in the protocol and see that it is, increasing by 2 and just do 20 instead of 18 and just redo the whole problem like you did prior?
Yeah, that's what we're going to do. Yeah. Yeah, that's the next step is, and you did that right. Like, so, because sometimes, and I'll be the first one to tell you that I wasn't sure what this meant initially when I first looked at this, like to increase the rate by 2 units per kilogram per hour. But what we're going to do is exactly that. We started at 18, we're going to increase by 2. So now we're going to be doing 20 units per kilogram per hour. And that's exactly right. So 50 kilograms, this is part C2, by the way, times the 20 kilograms, 20 units, kilogram hour. That'll give me 1,000 units per hour. Again, this looks very similar to question 22. And then I'm going to still multiply by what I have available because it's the same IV. I mean, maybe they switched it out, but it's the same dosing. And then you're going to get 10 milliliters per hour. If you did what I did initially and you took 9 milliliters per hour, added 2 and got 11 milliliters per hour, just know that you can't do that. So what if I give you another scenario? Let's take a different patient with a different weight, and then we'll do a different APTT. So it'll be completely different. So let's take a patient that weighs, let's just do a bigger number. Let's do 287 pounds. Okay. And this patient's 287 pounds. We need to calculate and put that into kilograms. So divide by 2.2. And I'm going to get 130.454545 repeating. So I'm going to round that number to 0.5. I will say this, when you're doing weight-based calculations, all these rules kind of change when we're talking about pediatrics versus like adults, right? Because pediatrics metabolize differently, smaller bodies and things like that. And so the decimal points, the smaller kilogram things have a lot more significance than maybe they do as an adult, because an adult is going to metabolize differently. But then you get past a certain weight, certain level of metabolism that you're still within a safe range. But that would be something that you guys are actually going to do for third semester is you'll take pediatrics with Professor Kowalski, and you will have a separate pediatric dosage test. And it'll be more about just understanding significance of safe ranges. All right. So I told you I'd give you another scenario. So let's say this patient's already gone through, has already done his initial bolus, has already started to drip at 18 units, but now I want to, I check on him after 6 hours, and then he has an APTT of 35 seconds. Okay. So, well, let's make it simple. Let's just say 30 seconds. Okay. So he's still clotting too frequently. Okay. So what are we going to do? If the APTT is 30 seconds, I'm going to follow the protocol in step 11 of the protocol. And it says we're going to rebolus, and then we're going to increase the rate by 4. So I rebolus with 80. So it's basically the same thing we did initially. And then I'm going to increase the rate by 4. 18 plus 4 is 22. Okay. So that's where we get those numbers from. So if you didn't do the initial bolus, you could still calculate the new information by just adding 14 or 18 plus 4. So step 1, rebolus times the 80 units per kilogram. So 80 times 130.5. It's 10,440 units. We're talking about bolus. So we're going to use the bolus strength. And that's going to give me, I think it's 10.44. Yeah, 10.44. And I'm going to round that to the nearest 10th. So it'll be 10.4 milliliters. Then we need to calculate the new flow rate. Yep, you got it, Jared, 10.44, and then round it to the nearest 10th. I'm going to do my new flow rate. This time it's 22 units per kilogram per hour. Which will give me, 2,871 units per hour. Then I'm going to do the same. Now I'm going to look at my IV bag, 250 milliliters, 25,000 units heparin. Divide by 100. And I'm going to get 28.71 milliliters per hour. And again, I'm going to round that to the nearest 10th, 28.7 milliliters per hour. Now, I always say this too. This is the math part of this. In reality, you may only be able to set the infusion pump to 30 milliliters per hour. That might be the lowest it goes for this particular scenario. But if it could, or, get down to the, to this, I would say just make sure you're at least getting down into the 10th place. If there's a question on that, you just need to verify that with your instructor. The other thing is, if you had not rounded your pounds to kilograms, you might come up with a slightly different answer. And you just have to keep that in mind. I only mention that because I'm not the one grading your test. If I was the one grading your test, I would pay attention to that. And then I would, as long as it followed the rules as far as what you are supposed to do or allowed to do as a, clinician, I would make sure that that was within the rules of the game. But my advice to you is, once you convert pounds to kilograms, go ahead and round that number to the nearest 10th and just work from there. When I create the keys, or when I have created the keys, that's how I did it. Okay. So, and then I would round one more time at the end. And just something to keep in mind, because I know many of you are not keeping that 130.45454545 in your basic 10 key calculator there. So, Are there any questions on the heparin protocol? Okay. Yeah, I gave, and like I said, there's a couple other variations that I did on Tuesday where I just used a different patient weight, and I use this again, that less than 35 seconds APTT, just to give you some additional practice with that. And that's how you practice these. Just change the patient's weight. I would say stick within the 36 to 44 second range, because that's probably what you'll get asked on the test. I don't remember off the top of my head. Technically anything's fair game, but that's how that would be. All right, and then someone asked about 20 and 21. I'll just show you how to set these up, because you know how to do these. 20 is pretty straightforward. You're just going to choose the strongest concentration, which is 20. And then 60 divided by 20 is 3 milliliters. Okay. For 21, if you didn't see this last semester, 21 is you have extra information. You don't care about the milliliters dilute and added. That's just extra information. That tells the pharmacy how much water to add to the powder to get to the concentrations. So again, choosing the strongest concentration, you look for the biggest number. The 1 million units per milliliter is the stronger concentration. So 350,000 units divided by a million, and then you get 0.35 milliliters. You leave it at 0.35 milliliters and do not round that to the nearest tenth, because your rounding rules say a number less than 1, round to the nearest hundredth. Okay. If it's a number greater than 1, like 1.35, then you would round it to the nearest tenth. You're welcome. Yeah. Any other questions?
Excuse me. Question 21, I guess you're looking for milliliters, not
Correct.
units.
That is correct. For 21, you're looking for milliliters. Yes. 0.35 milliliters would be your answer. Yes. Yeah. So for 24, once you calculate how many hours the infusion has gone, so all I did was 1,000 divided by 50, you get 20 hours. Then once you know it's 20 hours, you know that 24 hours from Monday at 8 a.m. is Tuesday at 8 a.m. And then so 20 hours is 4 less than 24 hours. So just 8 a.m. and then minus 4 would be 4 a.m. or 0400 if you have to do military time. Yeah, and then as far as the question on the 21, if you take the 350,000 units divided by 1 million units times milliliters, that's where that 0.35 milliliters is where you get the answer. This milliliters is just how much water was added to the powder to get to this concentration. So this just tells the pharmacy what to do. This doesn't help you out math-wise. This just tells you what the pharmacy, and this is what you would see on the drug label. If you have kids and they've ever been on, an oral antibiotic, that suspension like Augmentin or amoxicillin or something like that in the pharmacy, like you as the parent, you get that from the pharmacy, and it's already been, the suspension has already been made for you. But if you worked in the pharmacy, it would say on the label, fill it up to this line to get to this concentration, and then give the patient an oral syringe and tell them to administer based off of, what the medication says on the label, what was ordered. So if they're supposed to take 500 milligrams twice a day, then whatever that is, from an oral suspension standpoint, you would just follow that. But this just tells the pharmacy how much water to add. And I have heard that some of you, like when you get out, or even currently, if you're working in like nursing home or assisted living, or you're working somewhere where you are doing the suspensions, then, you know, this is important for knowing how much to add, but it doesn't tell you how much to administer. That's what the question is asking, how much to administer. This just tells me how to make the concentration. I hope that helps. All right. Well, I'll also be here this evening for you guys. So at 5 o'clock is the next time. And then I will post this review on YouTube later this evening or tomorrow.